Hello everyone and welcome back to another video in the Golang series. Today we are going to continue where we left in the goroutines video, and I hope you've watched this. If not, please go ahead and take a look and try to get a little familiar with what goroutines are. I've left a README file that might be helpful for you. And so in this video we are going to talk about channels. So I've created another folder for this. And basically, channels, it is sort of a shared memory between Go routines. So, Go routines, they run concurrently, but what if they need to communicate if there's some information that one of them is working on and the second one needs to take that? I mean, in that case, we use what is known as channels. So let's see a very quick example on what channels are, and then I'll try to take more detailed one to show you how it might actually work. So a channel can be, it's easy to make a channel. It's just make and you write chan, which is basically short for channel, and then you tell what kind of channel it is and what kind of input it might have. So let me just say it will have something, some string input. Could be, I don't know. Um, and let's say you have two Go routines. Let's say Go first, and then you say Go second. Uh, it doesn't really matter what these functions do for me at this point, so I'm not going to, make very detailed functions right now. I just want you to see how the syntax looks like. And if you've been through the coroutines video, you know this is not sufficient right now because um, the main function will end, so we need something known as wait group. So let's go ahead and declare that as well. RWG is equal to sync dot wait group. Okay, what did I do? Oh, okay. I again missing something. What did I miss? RWG sync group. Yeah, it's not. Sorry, my bad. Okay, and then we'll use the newer syntax to call this function. We'll just say something like wg dot go. It will take a function, um, and this function will call first. We need to define what first do does. We'll come to that. That's fine. We'll do one more. Let's call it second, and let's say wg dot wait. Cool. Now let's define the first function. What will it will take a channel of type string. Let's name it ch. And let's say I don't know. Let's say it writes some string. So let's assume some process gives output uh, hello. So what we are just going to do is I'm just going to make this first. I'm just going to make the first function write hello to the channel, and that is going to be processed by this second. So let's say func second chan string. So again, I know it might probably not make a lot of sense right now, but we'll see a proper example at the end. I just want you guys to look at the syntax for now. Process the input from channel. And so now when you are writing something to the channel, so generally in most of the languages you use this syntax, but in Go or for at least for channels it's the opposite. The arrow points to the variable to which the data is flowing. So let's say I write in hello. That's it. And now if I just use fmt dot print ln, it will sorry, what? Oh, that's fine. Now here we will write now. As I mentioned, the data flows in the direction of the arrow. So I can write something like ch. Basically, it means the data is flowing out of ch, and let's run it. That's actually uh, how we write or use channels in Go. Run main. Go. Cool. Hello. Now, what exactly is the use case? Why is it need for concurrency? Let's say you have a kitchen. In a kitchen, you'll have a waiter and a chef, right? So let's say a customer comes in. Waiter takes order. Now, waiter is one go routine that this is what I'm imagining. This is a go routine. So the only purpose of this go routine is to take orders and pass on that information. So there's going to be a chef. The chef is also going to be a go routine, and it will process the order. Now, both of these can happen concurrently, right? There's no dependency exactly. The only thing is that they need to communicate. The waiter needs to be able to tell that, okay, we've got something, please process it. And so what can happen is, let's say there's a function waiter, and let's say it takes in the same channel. What is it going to do? It might have, uh, let's say there's an uh, orders array. It will be of type string. And let's say what does it have? It has a pizza, it has a burger, it has pasta. That's fine. That's fine. I think three is fine for now. What else do we need? Uh, it is going to mm, okay. It is going to uh, it's going to iterate over this for I range orders orders. Okay. It is going to write to the channel orders of I. That's it. Now, one thing actually before I execute this, I want to show one thing I missed earlier. So this is a general producer consumer problem if you've seen, right? This is a producer, it's writing something to the channel, and this is something that is listening to the channel. Now, what happens if I actually don't write anything to the channel? And if I run this, it will give you an error saying deadlock. If there's a listener, there have to be a producer. So please consider this. There's also a command you can use, go run minus minus go run main.go minus minus race. Yep. So it kind of tells you that there's something wrong over here. And what happens if I don't do this? Uh, Again, someone needs to listen, right? I mean, why are we writing to this channel if there's no one who's going to listen to this? So please take care of this. Okay, back to this. So there's a function waiter who is writing, and then let's say there's going to be a function chef. Now the chef is also going to be connected to the same channel, string. And what is it going to do? For I in range channel. Uh, I don't think this bracket's needed. Hmm. Okay, what is the chef gonna say? Empty dot print f. Preparing orders for percentage b. Um, I guess that should be good. I guess. Cool. And now we just want to call these. All right, let's clear. Oops, I still got something. All coroutines are asleep and deadlock. Huh, what's happening? I don't know. Let's see. fmt.println. Cool. So we got that it is preparing pizza's order for pizza, it is preparing for burger, it's preparing for pasta. Then so it did everything, right? It was able to process everything. Then why did we run into deadlock after everything was processed? Now again, see, this channel is when we write this, we are basically opening a connection, and that connection also needs to be closed. Otherwise, this producer itself is going to keep waiting for something to happen. So once you're done with the channel, just write ch dot I think close ch, okay, close ch, my bad. And now when you run it, there you go. So please remember to do this, very important. So now when you make Go routines, you probably won't have anything like this. It's a very generic example. But the pattern remains same. You just need to make a channel to talk with the Go routines, and then it is gonna, you know, it's gonna start doing some processing, and then it writes over to this channel. And as soon as something is added to this channel, this listener or the consumer is going to start working on this. One important thing to note over here is one thing that I couldn't figure out initially was I used a for loop, right? So said while for I in range channel. But generally, when you do a range, it kind of gives you a size, right? It says channel is of size 3 if I iterate 3 times. But here it's not the same case. It basically is a it's it serves the same purpose as a while loop. As long as the channel keeps getting something, the chef will keep working on it, or the consumer will keep working on it. So I hope this part is clear. And actually, this is pretty much all I want to talk about the channel for now. And yeah, see you guys in the next video. Take care. Bye bye.